So welcome to the video. This we have here an ALU with a full adder and a 4x1 multiplexer. This is our full adder. We can see it over here. That's what I'm circling over, the full adder. This is our 4x1 multiplexer and some logic gates as well. So we are about to see how this ALU with full adder works. And a quick reminder that this is logic circuits, and logic circuits function on binary or operate using binary, right? Or perform their operations using binary. So all our inputs, all our outputs, everything is in base 2, right? This circuit works using a truth table. Now let me quickly display this truth table. I think I took a picture of it. Okay, so look to your left hand side, you see we have the truth table here. Now this truth table is what this logic circuit is going to work on. A quick reminder again that this circuit is performing all operations in binary. It's performing all its operations in binary because it's a logic circuit. Logic circuits perform binary operations. So hence our truth table, we shouldn't be seeing any values like 2. No, because when you are you know adding these two, let me first introduce you to the sum quickly so that you understand what I'm come to say. Now we have our sum here. This sum simply means addition, right? Sum, the sum we know in mathematics, sum, right? Sum of what? Sum of these inputs, A, B, C in. As you see here, A, B, C in. Now, what do these inputs tell, or what do these inputs entail? They control what is supposed to be outputted. What is supposed to be outputted? That is what's the truth table. Let's take our first row of the truth table. Now, as I mentioned it down, sum means addition, right? So we are adding all these three inputs, A, B, C in. A, B, C in. Now, our A is 0, our B is 0, our C in is 0. C in is carry out. Now, 0 plus 0 plus 0 should give you 0. So that's our sum. Our sum is 0. Our carry out is 0. How do we test it on this logic circuit? Now, we have a multiplexer here, and this will help us toggle or switch between the sum output and the carry out output. We want to display the sum output right now. What do we do? This multiplexer, let me quickly, this multiplexer has two selector inputs, right? Let me toggle them off. Let me switch all of them off. All right. This multiplexer has two selector inputs, right? Now, when we want to display whatever is in the end gate over here, we simply leave it as it is 0, 0. It will display whatever is supposed to be at this end gate. If we want to display whatever is at this OR gate, we simply switch the top selector input to 1, and it will display whatever is at this OR gate. If you want to display what's at this SUM gate, which is what you want to achieve or what you want to do right now, we simply switch here back to 0, and then we switch here to 1. Now, when we switch this part to 1, what do we see? We see that our sum is indeed 0. We have three inputs being 0 from the truth table. I displayed the three inputs are all 0, 0, 0, 0, A, B, C, they are all 0. And we are saying our sum as the output will be 0. So we just switch to the sum, and indeed our output is 0. Now let's switch to the carry out and see what our output will be. Per the truth table, our carry out is also 0 as well. So we are supposed to get 0 when we switch. How do we switch the carry out output? We simply switch the selector input at the top in the multiplexer to 1. So when we do that, we switch to the carry out. part. So it's supposed to display what's at the carry out. What do we see at the output? Zero, which means our truth table is, or this circuit is following our truth table we showed. Now, let's move on to a different scenario where we have one of the three inputs A, B, C in to be one, any of them. Now, in this case, our C in is one. C in means carry in. I think I've mentioned that already. Now, C in is one. Sorry, when our C in is one, what happens or what do we see? What is supposed to be our output? Now, when C in is one, you are simply sorry, for the to get the sum, you are simply going to add C in and B and A, right? A is 0, B is 0, C in is 1. Now 0 plus 1 should give you 1 as your sum, right? And that's indeed true. So it means that when we switch our circuit, or when we want our circuit to confirm this and we switch to the sum, we are supposed to get an output of 1 over here. What about our carry out? Our carry out will be 0 because there is nothing to carry out. There is nothing to carry out. Remember, we are doing this in base 2 and addition in base 2, and you have when all the numbers are below base 2, there is supposed to be no remainder or no carryouts. Carryouts can be also interpreted as a remainder. So that is why carryout is 0. Now let's confirm this. Our sum, sorry, when we have any of these inputs to be 1, which in this case the C in was 1, our sum is supposed to be 0. Let's switch to our sum. Now that's what we see here. We see that the output is 1. This is following the truth table. This logic circuit is indeed following the truth table. Our sum is 1. What about our carryouts? We switch to our carryouts and you see that our carryout is 0. Our carryout is 0. So it's following our truth table. Now let's look at a different scenario here. Let's look at a different scenario here where we have two numbers. Let's move to our 1, 2, 3, 4, fourth row in the truth table. In the truth table, the fourth row, let's see what we have here. Now we see that two inputs are each having 1 1. B and C in this case, B and C in have 1 1 each. What happens? Once again, I am reminding you that this truth table or this entire operation is in base 2. So what happens when you are adding two numbers in base 2, or when adding numbers in base 2, no number is supposed to exceed the base number, which is 2 in this case because it is in base 2. But here we have 1 plus 1, which is 2. 1 plus 1, which is 2. Since it is 2, what do we do? What do we do? Now, from number basis, I'm sure most of us have done number basis. For number basis, for number basis, we simply write our sum down as 0, and then we carry 1 out. We carry 1 out. So that's what we see here. This is in base 2. Once again, we've added this and this 2. 2 we cannot write 2 in base 2. We are doing this in base 2. So what do? We write our sum as 0, then we carry 1 out. We write our sum as 0, then we carry 1 out. So our sum in this case is 0, our carry out is 1. Let's see if our logic circuit agrees with what we are saying. So let's go back. Our two inputs B and C in were 1. Now, yes, so this is already on a carry out output, and we see that our carryout was 1 from the truth table. Our carryout was 1, and that's what you are seeing. The output for the carryout is 1. The two inputs here are 1 1 each, and this is 0. So this confirms our truth table. What about the sum? The sum was 0. Let's see if that's also true as well. That is also true. Let's see. We toggle this one here, and yes, we see that our sum is 0. This means that the truth table or the logic circuit here is indeed following the truth table. Now, let's go to our last scenario where each of the three, or all the three inputs are one, all the three inputs are one, what happens? Look to the last row of the truth table. 1, 1, 1. Now our sum is 1, our carry out is 1. Our sum is 1, our carry out is 1. From number basis, as I said, we are doing this in base 2. So when we add the inputs, so we add the numbers, we are not supposed to get any number that is greater than 0 and greater than 2 or equal to 2. In this case, when we add the input A, B, C in, we are getting 3 because they are all 1, 1, 1. We are getting 3. 3 is greater than 2. Now, since we are working in base 2, what do? We simply subtract 2 from 3. We subtract 2 from 3. Now, the result being 1 is what we are going to write for our sum. When we subtract 3 from 2, our result is 1. That is what we are going to write as our sum. Now, there is going to be a remainder 1. Now, you will carry that one out. Carry that one out. That is how come we have our sum to be 1. Now, carry out also to be 1. Now, let's confirm this in our circuits, our ALU circuits. Now, we simply switch this one to 1. So our A is 1, B is 1, C in is 1. And we see that our sum has already been switched on. So the output for our sum is 1, as I mentioned earlier on. From the truth table, the sum for the output for the sum is 1. What about the carry out? Let's switch the carry out. The output for the carry out is 1 as well. So that is how this ALU circuit with a full adder works. That's how it works. Thank you for your time.